Have you ever wondered what our solar system might feel like when night grows deep on Earth? Perhaps on a distant planet, winds are blowing faster than the speed of sound. Somewhere beneath an icy moon, a quiet ocean may be hidden. And somewhere, ancient light, billions of years old, is still slowly traveling through the darkness of space. Tonight, we are not in a hurry. We will simply drift gently through the solar system, from one planet to another, from one mystery to the next. So gently close your eyes, let your breathing slow down, and imagine yourself floating lightly through space. Because tonight we are going to drift slowly through some of the most peaceful and astonishing mysteries of our solar system. Tonight, there is nowhere you need to go and nothing you need to finish. The day has slowly faded and the quiet of night has gently taken its place. So allow your shoulders to relax, let your breathing become slow and steady, and imagine that the weight of the world is becoming lighter and lighter, as if gravity itself has softened its grip. Because tonight, we are going to take a slow and peaceful journey through our solar system. Not a fast journey like a rocket launch, instead something softer, something calmer. Imagine drifting through space the way a feather drifts through still air, moving slowly, quietly, and without effort. Our story begins at the center of everything we know in this cosmic neighborhood, the sun. From Earth, the sun appears calm and constant, rising every morning with warm golden light. But deep inside, the sun is a restless and powerful engine of energy. At its core, temperatures rise to nearly 15 million degrees Celsius, and the pressure is so immense that tiny hydrogen atoms are forced together. When they collide under such extreme conditions, they fuse together and form helium. This process is called nuclear fusion. Every single second, the sun converts nearly 4 million tons of its own mass into energy. That energy travels outward through space as light and heat, spreading in all directions across the solar system. Some of that light eventually reaches our small blue planet. But the sunlight touching Earth right now did not begin its journey a few minutes ago. Inside the sun, energy moves slowly through dense layers of hot plasma. Photons of light bounce endlessly from particle to particle, sometimes wandering inside the sun for thousands, even hundreds of thousands of years before finally escaping into space. Only after that long journey does the light finally begin its rapid trip across the solar system. Once free, light moves incredibly fast, traveling at nearly 300,000 kilometers every second. Even at that unimaginable speed, it still takes about 8 minutes for sunlight to reach Earth. Those 8 minutes connect our quiet planet to the heart of a star. But the sun does more than simply shine. Its gravity acts like an invisible anchor holding the entire solar system together. Every planet, moon, asteroid, and comet moves according to its powerful pull. Without the sun's gravity, the planets would simply drift away into the darkness between stars. Instead, they follow elegant paths through space, circling again and again in quiet orbits that have continued for billions of years. And the closest traveler in those graceful paths is a small rocky planet racing around the sun faster than any other world. A planet where a single year passes in only 88 Earth days. As we continue drifting outward through the warm glow of the sun, our next stop waits quietly ahead, the swift and mysterious planet Mercury. As we drift a little farther from the sun, the bright glow behind us slowly softens, and ahead of us appears the smallest planet in the solar system, Mercury. From a distance, Mercury looks like a quiet gray sphere covered with countless craters and scars left behind by ancient collisions. Its surface resembles the Moon more than any other planet, marked by billions of years of impacts from wandering rocks and fragments of space. But despite its calm appearance, Mercury lives in one of the most extreme environments in the solar system. Because it orbits so close to the Sun, this tiny planet experiences enormous swings in temperature. During the long Mercurian day, sunlight pours down with intense heat, raising surface temperatures to nearly 430 degrees Celsius. That is hot enough to melt lead. Yet, when night falls, the temperature plunges dramatically. Without a thick atmosphere to trap heat, Mercury cools rapidly, and the surface can drop to nearly minus 180 degrees Celsius. Few places in the solar system experience such dramatic changes between day and night. Mercury's days are also strangely long. The planet rotates very slowly on its axis. One full rotation takes about 59 Earth days. But Mercury also moves quickly around the Sun, completing one full orbit in just 88 Earth days. This unusual combination creates a strange rhythm of sunlight and darkness across the planet's surface. On Mercury, a single sunrise to the next sunrise lasts about 176 Earth days. Imagine standing on Mercury and watching the sun slowly climb into the sky. It would move so slowly that hours might pass before you notice any change at all. And Mercury's sky would look very different from ours. Because the planet is so close to the sun would appear more than 3 times larger than it does from Earth. The sky itself would remain completely black, even during daytime, since Mercury has almost no atmosphere to scatter sunlight. In fact, Mercury doesn't really have an atmosphere at all. Instead, it has something scientists call an exosphere. An exosphere is an extremely thin cloud of particles surrounding a planet, so sparse that atoms rarely collide with one another. On Mercury, this ghostly layer is made of atoms blasted off the surface by solar radiation and tiny meteoroid impacts. Sodium, potassium, oxygen, and even traces of hydrogen drift briefly above the surface before escaping into space. It is less like air and more like a delicate veil of scattered atoms. Despite these harsh conditions, Mercury still holds a quiet surprise. At its poles, deep inside craters that never receive sunlight, temperatures remain permanently cold. These shadowed regions act like natural freezers, allowing water ice to survive for millions, perhaps even billions of years. So, on one of the hottest planets in the solar system, frozen ice quietly waits in eternal darkness, a strange and peaceful contradiction. As we slowly continue our journey outward, leaving Mercury's cratered landscape behind, another world begins to appear ahead through the soft glow of sunlight. A planet wrapped in thick clouds, a world where the sky hides everything beneath it. The mysterious planet, Venus.
As Mercury slowly fades behind us, another world emerges through the golden light of the sun. From a distance, it appears soft and luminous, wrapped in smooth layers of pale clouds. This is Venus. At first glance, Venus might seem like a twin of Earth. It is nearly the same size, made of similar rocky materials, and formed around the same time in the early history of the solar system. For a long time, scientists even wondered if Venus might be a lush, ocean-covered world hidden beneath those thick clouds. But the truth turned out to be very different. The clouds surrounding Venus are not made of water. Instead, they're thick layers of sulfuric acid swirling endlessly through a dense and heavy atmosphere. This atmosphere is made mostly of carbon dioxide, trapping heat in an extreme greenhouse effect. Because of this, Venus has become the hottest planet in the entire solar system. Surface temperatures reach around 465 degrees Celsius, hot enough to melt lead and even damage many spacecraft within a short time. The heat remains nearly the same day and night because the thick atmosphere holds warmth like a massive thermal blanket. Standing on the surface of Venus would be an overwhelming experience. The air pressure there is about 90 times greater than the pressure on Earth. That is similar to the pressure you would feel nearly 1 kilometer beneath the ocean. Any human visitor would be crushed long before they could take a single step. Yet, despite these extreme conditions, Venus has one of the most fascinating rotations in the solar system. Unlike most planets, Venus spins backward. This strange motion is known as retrograde rotation. While Earth and most other planets rotate from west to east, Venus turns in the opposite direction. Because of this, the Sun would appear to rise in the west and set in the east if you were somehow standing on the planet's surface. And Venus turns incredibly slowly. A single rotation takes about 243 Earth days. That means one day on Venus is actually longer than its entire year, since the planet only takes about 225 Earth days to travel once around the Sun. So on Venus, a day lasts longer than a year. Scientists still debate why Venus rotates this way. One possibility is that long ago, during the chaotic early days of the solar system, a massive collision may have flipped Venus's rotation. Another idea suggests that powerful tidal forces from the Sun slowly altered its spin over millions of years. Venus also hides another important difference from Earth. Unlike our planet, Venus has almost no global magnetic field. Earth's magnetic shield protects us from streams of charged particles coming from the Sun, but Venus lacks this protective barrier. As a result, solar winds have slowly stripped away lighter elements from its atmosphere over billions of years, helping transform Venus into the scorching world we see today. It is a reminder that even planets that begin in similar ways can follow very different paths. As we drift quietly away from this blazing, cloud-covered world, another familiar blue planet waits farther out in space. A small world filled with oceans, clouds, and life. Our home, Earth. As we continue drifting gently outward from the Sun, the bright clouds of Venus slowly fade behind us. Ahead, a small blue sphere begins to glow softly in the darkness of space. This is Earth. From afar, Earth appears calm and delicate, wrapped in swirling white clouds and deep blue oceans. It is the only known world in the solar system where life exists, a rare balance of water, atmosphere, and temperature that allows living things to thrive. Nearly 70% of Earth's surface is covered by oceans, vast bodies of water that reflect sunlight back into space. These oceans play a crucial role in shaping the planet's climate, storing heat, circulating nutrients, and supporting countless forms of life beneath their shifting waves. But the surface of Earth is not still. Beneath the continents and oceans lies a restless system of moving pieces known as plate tectonics. Earth's outer shell is divided into enormous plates of solid rock that slowly glide across the softer layer of mantle below. These movements are incredibly slow, often only a few centimeters each year, about as fast as your fingernails grow. Yet, over millions of years, these slow motions reshape entire continents. When plates collide, mountains rise slowly toward the sky. When they pull apart, new ocean floors form deep beneath the sea. And when they slide past one another, the tension sometimes releases suddenly as earthquakes. This system of shifting plates is unique among the planets we know. Mars and Venus show signs of ancient volcanic activity and fractured surfaces, but they do not appear to have the same active, moving crust that Earth does today. Plate tectonics also helps regulate Earth's climate over long periods of time. Carbon dioxide from the atmosphere becomes trapped in rocks and eventually recycled through volcanic activity. This slow cycle helps keep temperatures stable enough for oceans and life to persist. Deep inside the planet, another powerful process is taking place. At Earth's core lies a vast sphere of iron and nickel. The outer part of this core is molten metal, constantly moving and swirling due to intense heat rising from the center of the planet. These flowing metals generate Earth's magnetic field. This invisible shield stretches far into space, protecting the planet from the constant stream of charged particles released by the sun. Without this magnetic barrier, much of Earth's atmosphere could slowly be stripped away by solar winds, much like what happened to Mars long ago. Earth is also the densest planet in the solar system. Although giant planets like Jupiter and Saturn are much larger, they are mostly composed of lighter gases. Earth's dense mixture of metals and rocky materials packs more mass into each cubic centimeter than any other planet. This compact structure contributes to the strong gravity that holds our oceans and atmosphere close to the surface. From the quiet distance of space, Earth appears peaceful, but beneath the clouds and oceans, it is a world constantly changing, shifting, and renewing itself. And as we slowly continue our calm journey outward through the solar system, another familiar red world begins to appear ahead. A dusty planet marked by enormous volcanoes and vast canyons. The mysterious world of Mars.
As Earth slowly drifts behind us, a new world begins to appear ahead in the darkness of space. At first, it looks small and faint, glowing with a dusty reddish color under the distant sunlight. This is Mars. For centuries, Mars has fascinated human imagination. Its warm red color, caused by iron-rich dust covering its surface, makes it one of the most recognizable planets in the night sky. Even from Earth, ancient observers noticed its unusual brightness and wandering path across the stars. But up close, Mars reveals a landscape both beautiful and haunting. The planet is covered in deserts of fine reddish dust, rocky plains, ancient riverbeds, and enormous volcanic mountains. Though it appears quiet today, Mars once had a far more active and dynamic past. Billions of years ago, liquid water likely flowed across the surface. Evidence of this ancient water can still be seen today. Dry channels snake across the landscape, carved by long-vanished rivers. Smooth stones and mineral deposits hint that lakes and perhaps even shallow seas once existed here. Today, however, Mars is cold and dry.
The planet's thin atmosphere, composed mostly of carbon dioxide, is far too weak to trap much heat. Average temperatures hover around -60 degrees Celsius, and the air pressure at the surface is less than 1% of Earth's. Because the atmosphere is so thin, Mars cannot hold heat well. During the night, temperatures fall sharply, and even during the day, the warmth of the sun feels faint and distant. Yet Mars is far from completely still. One of its most dramatic features is the massive canyon system known as Valles Marineris. Stretching over 4,000 kilometers across the Martian surface, this enormous canyon would span nearly the entire width of the continental United States. In some places, it plunges more than 7 kilometers deep, making it far deeper than Earth's Grand Canyon. Scientists believe this colossal fracture formed when Mars's crust stretched and cracked during ancient volcanic activity. Not far from these deep scars stands the tallest volcano in the entire solar system, Olympus Mons. Rising nearly 22 kilometers above the surrounding plains, Olympus Mons towers almost 3 times higher than Mount Everest. Its base is so wide that it could cover an entire U.S. state. This gigantic volcano formed over millions of years through repeated eruptions from a stationary hotspot beneath the Martian crust. Unlike Earth, Mars does not have moving tectonic plates. Because the crust remained still, lava continued to erupt from the same location again and again, slowly building one immense volcanic mountain. Mars also experiences powerful dust storms. Fine particles of rust-colored dust can rise high into the atmosphere and spread across vast distances. Sometimes, these storms grow so large that they engulf the entire planet, covering the surface in a thick haze that blocks sunlight for weeks or even months. In 2018, one of these global storms covered Mars completely, ending the long mission of the Opportunity rover when its solar panels became buried beneath layers of dust. Yet even through the silence of its deserts and storms, Mars continues to hold many mysteries. And as we drift quietly farther outward into the solar system, we begin to approach a region filled with scattered rocks and ancient fragments left over from the birth of planets. The wide and quiet expanse known as the asteroid belt. As Mars slowly fades into distance behind us, the space ahead begins to change. Instead of a single planet waiting in orbit, we enter a wide region filled with countless small remnants from the early days of the solar system. This quiet stretch of space is known as the asteroid belt. It lies between the orbits of Mars and Jupiter, forming a broad ring of rocky bodies circling the Sun. When people first hear about the asteroid belt, they often imagine a crowded field of tumbling rocks, like scenes from science fiction movies where spacecraft must dodge obstacles at every turn. But the reality is far calmer. The asteroid belt is mostly empty space. Although millions of rocky objects exist within it, the distances between them are enormous. If a spacecraft were traveling through this region, it would almost certainly pass through without encountering a single asteroid nearby. In fact, the total mass of all the asteroids combined is surprisingly small. Even if every object in the asteroid belt were gathered together, their total mass would still be less than 5% of the mass of Earth's moon. Most of that mass is contained in just a few of the largest bodies. One of these is Ceres. Ceres is the largest object in the asteroid belt, and is classified as a dwarf planet. It measures about 940 kilometers across and has enough gravity to pull itself into a nearly spherical shape. Unlike most asteroids, Ceres appears to contain significant amounts of water ice beneath its surface. Some studies even suggest that a layer of salty liquid may exist deep underground, making it one of the most intriguing worlds in this quiet region of space. Another large body in the belt is Vesta. Vesta is smaller than Ceres, but still enormous compared to most asteroids. Its surface is covered with deep impact scars, including one colossal crater near its south pole. This ancient collision blasted huge fragments into space, some of which eventually traveled all the way to Earth as meteorites. But many asteroids, however, are far smaller. Some are only a few kilometers wide, while others are little more than loose piles of rock and dust held together by weak gravity. These fragile bodies are often called rubble piles, the broken remains of larger objects shattered long ago. Surprisingly, some asteroids even have their own tiny moons. One famous example is the asteroid Ida, which has a small companion named Dactyl. Discovered by the Galileo spacecraft in 1993, Dactyl quietly circles its larger partner like a miniature moon orbiting a tiny world. These small gravitational partnerships remind us that even the smallest objects in space can become part of a system. The asteroid belt itself is believed to be made of leftover building blocks from the early solar system. When the planets were forming billions of years ago, gravity gradually pulled together clouds of dust and rock to create larger worlds. But in this region, the powerful gravity of nearby Jupiter disrupted the process, preventing a full planet from forming. Instead, countless fragments remained here, silent witnesses to the chaotic birth of the planets. And as we continue drifting gently outward through this quiet field of ancient stones, a massive presence begins to emerge ahead. A giant world surrounded by storms, gravity, and an entire family of moons. The immense planet, Jupiter.
As we slowly leave the scattered stones of the asteroid belt behind us, a massive shape begins to rise ahead of us in the darkness of space. At first, it appears as a faint banded sphere, but as we drift closer, its enormous scale becomes impossible to ignore. This is Jupiter. Jupiter is the largest planet in the solar system, so large that all the other planets combined would still be only a fraction of its mass. More than 11 Earths could fit across its diameter, and over 1,000 Earth-sized worlds could fit inside its vast volume. Yet, despite its size, Jupiter is not a solid world like Earth or Mars. Instead, it is a gas giant, made mostly of hydrogen and helium, the same elements that form the Sun. Beneath its colorful clouds lies a deep atmosphere that gradually becomes denser and hotter with depth, eventually transforming into exotic states of matter under enormous pressure. The planet's appearance is marked by broad bands of swirling clouds that circle the globe. These bands are created by powerful winds racing around the planet at incredible speeds. Some of these jet streams move at more than 600 kilometers per hour, constantly shaping the bright zones and darker belts that give Jupiter its striped appearance. But Jupiter's most famous feature is a storm unlike anything seen anywhere else, the Great Red Spot. This enormous swirling storm has been raging for centuries.
Astronomers first observed it more than 300 years ago, and it may have existed even longer before that. The storm is so large that several Earths could fit inside it. Though it has slowly shrunk over time, the Great Red Spot remains one of the most powerful storms in the solar system. Jupiter's immense gravity influences everything around it. Not only does it control a vast collection of moons, but it also helps shape the structure of the entire solar system. Many scientists believe Jupiter acts as a kind of cosmic shield, its powerful gravity capturing or deflecting comets and asteroids that might otherwise travel toward the inner planets. In this way, Jupiter may have helped protect Earth from countless impacts over billions of years. Jupiter also produces a magnetic field far stronger than any other planet. This magnetic field creates enormous radiation belts filled with high-energy particles trapped in invisible loops around the planet. These belts are so intense that they could quickly damage unprotected spacecraft passing too close. Even Jupiter's moons must endure this constant bombardment of radiation, and there are many moons. More than 90 moons have been discovered orbiting Jupiter, forming a complex miniature system of worlds. Some are tiny captured asteroids only a few kilometers wide, while others are enormous spheres with their own fascinating landscapes. 4 of these moons are especially remarkable. They were first observed in the year 1610 by the astronomer Galileo Galilei and are now known as the Galilean moons: Io, Europa, Ganymede, and Callisto. Each one is a unique world with its own mysteries waiting to be explored. As we drift closer to Jupiter's immense gravity, these distant moons begin to appear one by one, quietly circling their giant parent. And among them lies a particularly intriguing place, a frozen moon that may hide a vast ocean beneath its icy shell, the mysterious world of Europa.
As Jupiter's enormous clouds slowly drift beneath us, its family of moons begins to come into view. Dozens of small worlds circle the giant planet, each following its own quiet path through space. Among them, one moon in particular shines with a smooth, pale surface that reflects the distant sunlight. This is Europa. From afar, Europa looks like a frozen marble covered with bright ice, streaked by long, dark lines that stretch across its surface like cracks in glass. These markings form an intricate network of ridges and fractures, giving the moon a strangely beautiful appearance. But Europa's frozen exterior may hide something extraordinary beneath it. Scientists believe that under its icy crust lies a vast ocean of liquid water. Unlike Earth's oceans, which are mainly warmed by sunlight, Europa's hidden sea may be heated from within. The powerful gravity of Jupiter constantly pulls and squeezes the moon as it orbits, creating tidal forces that flex its interior. This constant flexing generates heat. Over long periods of time, that heat may be enough to keep a deep ocean from freezing solid, even though Europa is hundreds of millions of kilometers away from the Sun. The icy shell above this ocean is thought to be several kilometers thick. In some places, it may be cracked or fractured, allowing materials from the ocean below to slowly rise toward the surface. These frozen ridges and dark streaks are likely signs of this ongoing activity. Europa's ocean could be enormous. Some estimates suggest it may contain more than twice as much water as all of Earth's oceans combined.
If true, it would make Europa one of the largest reservoirs of liquid water in the entire solar system. And where there is liquid water, scientists often begin to wonder about the possibility of life. Of course, Europa's ocean would be a very different environment from anything on Earth's surface. It would exist in complete darkness beneath kilometers of ice, far from the warmth of sunlight. Yet even on Earth, life has found ways to survive in extreme environments. Deep in our own oceans, near hydrothermal vents on the seafloor, entire ecosystems thrive without sunlight. Instead of using energy from the sun, these organisms rely on chemical reactions driven by heat from Earth's interior. Some scientists believe similar processes might occur on Europa. If hydrothermal vents exist on the Moon's ocean floor, they could provide warmth, energy, and the chemical ingredients necessary for simple life to develop. For this reason, Europa has become one of the most intriguing targets for future exploration. Space agencies are planning missions that will study its surface more closely, searching for clues about the ocean hidden beneath the ice. As we slowly drift away from Europa's frozen landscape, other moons continue to circle Jupiter quietly in the background. One of them is far larger than the rest. In fact, it is the largest moon in the entire solar system, a world even bigger than the planet Mercury. Waiting ahead in the calm darkness is that enormous moon, the giant world of Ganymede.
As Europa slowly drifts behind us, another enormous moon begins to appear ahead. Its surface looks darker and older, marked by bright streaks, deep grooves, and vast regions of ancient ice. This is Ganymede. Ganymede is the largest moon in the entire solar system. In fact, it is even bigger than the planet Mercury. If it orbited the Sun instead of Jupiter, it could easily be considered a small planet in its own right. Yet, despite its impressive size, Ganymede quietly circles Jupiter once every 7 days, moving through space as part of the giant planet's vast family of moons. Its surface tells a story billions of years old. Some regions of Ganymede are extremely ancient, covered with countless craters left behind by impacts from comets and asteroids. These dark, heavily marked areas have remained largely unchanged for immense stretches of time. But other regions look very different. Across large parts of the Moon, bright bands of grooved terrain stretch for thousands of kilometers. These ridges and valleys formed long ago when Ganymede's icy shell shifted and cracked as the interior slowly cooled and expanded. The result is a patchwork landscape of old and new surfaces frozen together in time. Deep beneath this icy shell, scientists believe Ganymede may also hide layers of liquid water. Instead of a single ocean like Europa, Ganymede might contain several oceans stacked between layers of ice, forming something like a vast underground sandwich of water and frozen crust. But Ganymede holds another remarkable feature. It is the only moon in the solar system known to have its own magnetic field. This invisible magnetic shield likely forms from the movement of liquid metal within its core, much like the process that generates Earth's magnetic field. The result is a small magnetosphere surrounding the moon, interacting with Jupiter's much larger magnetic environment. Because of this magnetic field, colorful auroras sometimes glow near Ganymede's poles. These shimmering lights form when charged particles from Jupiter's magnetosphere collide with gases in the Moon's extremely thin atmosphere. The atmosphere itself is faint,
made mostly of oxygen molecules released from the icy surface by radiation. Though it is far too thin for humans to breathe, it still creates subtle interactions with the surrounding space environment. Ganymede's gravity is also strong enough to shape its own interior. Scientists believe the moon contains a layered structure with a metallic core, a rocky mantle, and thick shells of ice above possible oceans. This complex structure makes Ganymede more planet-like than most other moons. Yet, despite its size and fascinating features, Ganymede remains a quiet and distant world. From the surface, Jupiter would dominate the sky, appearing many times larger than our moon appears from Earth. Its swirling clouds would rise slowly over the icy horizon, casting faint light across the frozen plains. As we continue drifting through Jupiter's vast family of moons, another ancient world quietly waits nearby. A darker and even older landscape covered with the scars of countless impacts, a moon that has remained largely unchanged since the earliest days of the solar system. The silent and mysterious world of Callisto. As Ganymede slowly moves behind us, another large moon drifts into view. Its surface appears darker, older, and heavily marked with countless craters. From a distance, it almost looks like a world that has been frozen in time. This is Callisto. Callisto is the second largest moon orbiting Jupiter and one of the most ancient surfaces in the entire solar system. Nearly every part of its landscape is covered with impact craters, evidence of billions of years of collisions with comets, asteroids, and other wandering fragments of space. Unlike some of Jupiter's other moons, Callisto shows very little sign of internal activity. There are no towering volcanoes, no vast ridges formed by shifting crust, and almost no evidence that the surface has been renewed over time. Instead, the same ancient terrain has remained largely unchanged for immense stretches of cosmic history. Because of this, Callisto is often described as one of the most heavily cratered worlds known. Some of its largest impact structures are enormous. One of the most remarkable features on the moon is a gigantic ring-shaped region called Valhalla. At the center of this ancient impact basin lies a bright circular area surrounded by multiple rings of fractured terrain that stretch outward for thousands of kilometers. It is one of the largest known impact structures anywhere in the solar system. When the object that created Valhalla struck Callisto long ago, the collision released unimaginable amounts of energy. The surface rippled outward like waves spreading across a pond, leaving behind the concentric rings we see today. Despite its battered appearance, Callisto holds some intriguing mysteries beneath its surface. Scientists believe that deep below its thick outer layer of ice and rock, there may be a hidden ocean of salty liquid water. Evidence for this comes from subtle changes detected in Jupiter's magnetic field as the moon moves through it. These changes suggest a conductive layer, possibly liquid water mixed with salt, exists beneath the frozen crust. If such an ocean exists, it would lie hundreds of kilometers below the surface, sealed away in darkness and protected from the intense radiation surrounding Jupiter. Unlike Europa, however, Callisto's interior appears relatively quiet, with fewer signs of the heating processes that might support active geology. Still, its possible ocean makes it an interesting place for scientists studying the potential for water beyond Earth. Another remarkable feature of Callisto is its position within Jupiter's powerful magnetic environment. Because it orbits farther from Jupiter than the other large Galilean moons, Callisto receives far less radiation, making it one of the safer regions within Jupiter's system for future spacecraft missions. In fact, some scientists have even suggested that Callisto could one day serve as a base for exploring the rest of the Jovian system. From its quiet surface, Jupiter would appear as a huge striped sphere rising slowly above the horizon, illuminating the icy plains with reflected sunlight. For now, though, Callisto remains a silent witness to the ancient history of our solar system. And as we gently drift farther away from Jupiter and its moons, the next giant world begins to appear in the distance. A planet surrounded by shimmering rings of ice, the beautiful and mysterious. As Jupiter and its many moons slowly fade into the distance behind us, another giant world begins to rise ahead in the quiet darkness of space. Even from far away, something about this planet immediately captures attention. A wide, delicate halo surrounds it. This is Saturn. Saturn is the second largest planet in the solar system, a massive gas giant made mostly of hydrogen and helium. Though it is slightly smaller than Jupiter, Saturn is still enormous. More than 9 Earths could fit across its diameter, and hundreds of Earth-sized worlds could fit within its volume. Yet Saturn is also surprisingly light. If there were a bathtub large enough to hold it, Saturn would actually float in water. This is because the planet's average density is lower than that of water itself. But what truly makes Saturn unforgettable are its rings. These rings stretch outward for more than 280,000 kilometers, forming one of the most breathtaking sights in the solar system. From a distance, they appear solid and smooth, like a shining disk encircling the planet. But up close, the rings are anything but solid. They are made of countless individual particles of ice and rock, each orbiting Saturn like a tiny moon. Some of these pieces are no larger than grains of sand, while others are as big as houses. Together, billions upon billions of these icy fragments create the graceful rings we see. And despite their enormous width, Saturn's rings are astonishingly thin. In many places, they are less than 100 meters thick, thinner than many tall buildings on Earth. If you could somehow fly alongside the rings, you would see a vast, flat field of glittering ice particles drifting quietly through space. The rings are also divided into several major sections separated by dark gaps. One of the largest gaps is called the Cassini division. This region is not completely empty, but it contains far fewer particles than the surrounding rings. The gap forms because the gravitational pull of nearby moons influences the motion of the ring particles. In fact, several small moons known as shepherd moons help shape and maintain the rings. These moons orbit along the edges of the rings, using their gravity to guide the icy particles into narrow bands and sharp boundaries. Without these gravitational shepherds, the rings would gradually spread out and lose their elegant structure. Yet Saturn's rings may not last forever. Observations from spacecraft such as Cassini have revealed that tiny streams of icy material are slowly drifting inward toward the planet. This process, sometimes called ring rain, occurs when charged particles follow Saturn's magnetic field and fall into the atmosphere. Over millions of years, this slow loss of material may eventually cause the rings to fade away. For now, though, they remain one of the most beautiful sights in the solar system. Saturn is also surrounded by a remarkable collection of moons, each with its own strange and fascinating environment. More than 80 moons have been discovered so far, ranging from small irregular rocks to large worlds with thick atmospheres and hidden oceans. Among them is one of the most intriguing moons anywhere in the solar system, a distant world where rivers, lakes, and rain exist, but not made of water. Instead,
They are made of liquid methane. Waiting quietly in Saturn's orbit is that extraordinary moon, the mysterious world of Titan.
As Saturn's glowing rings slowly drift behind us, one of its largest moons begins to appear through the soft sunlight. At first, it looks like a pale orange sphere wrapped in thick haze, its surface completely hidden beneath a dense atmosphere. This is Titan. Titan is Saturn's largest moon and the second largest moon in the entire solar system, surpassed only by Jupiter's moon, Ganymede. What makes Titan especially fascinating is that it is the only moon known to possess a thick atmosphere. This atmosphere is composed mostly of nitrogen, much like Earth's, but it also contains methane and other complex hydrocarbons. These gases form a hazy orange blanket that completely hides the surface from ordinary view. For a long time, scientists had no idea what Titan's surface looked like. Everything changed when the Cassini spacecraft arrived at Saturn and began studying Titan in detail. Using radar instruments capable of seeing through the thick clouds, scientists finally revealed the moon's hidden landscape. What they discovered was astonishing. Titan has lakes, rivers, and even seas. But unlike Earth, where these bodies of liquid are made of water, Titan's lakes are filled with liquid methane and ethane. Because the moon is extremely cold, with surface temperatures around -180 degrees Celsius, methane behaves much like water does on Earth. It can exist as a solid, a liquid, or a gas. This creates a methane cycle similar to Earth's water cycle. Methane evaporates into the atmosphere, forms clouds, and eventually falls back to the surface as rain. These rains slowly carve channels across the icy ground, feeding rivers that flow into lakes and seas. Some of Titan's largest seas stretch hundreds of kilometers across its northern regions. From orbit, they appear as dark, smooth shapes against the lighter terrain surrounding them. One of the largest, Kraken Mare, is so vast that it resembles an alien ocean on this distant world. Beneath Titan's icy crust, scientists believe another ocean may exist. Deep underground, a hidden sea of liquid water mixed with ammonia could lie beneath the frozen outer shell. This ocean would be sealed away from the frigid surface, warmed slightly by heat from the moon's interior. Titan's thick atmosphere also creates a unique environment. Because the air pressure at the surface is about 50% greater than Earth's and gravity is much weaker, flying on Titan would be surprisingly easy. In theory, a person wearing wings could glide through the dense air with very little effort. The sky above Titan would appear dim and orange, with sunlight filtered through layers of haze. Saturn itself would occasionally appear in the sky as a pale, ghostly shape far above the clouds. Titan is also rich in complex organic molecules. These chemical compounds are considered some of the building blocks of life. While the moon is far too cold for life as we know it to exist on the surface, its chemistry offers scientists valuable clues about how organic molecules might form throughout the universe. Because of these fascinating features, Titan has become one of the most important targets for future exploration. Space missions are already being planned to send robotic explorers to its mysterious surface. As we slowly drift away from Titan and Saturn's magnificent rings, the sunlight grows dimmer and colder. Farther out in the solar system, two distant giant worlds wait quietly in the darkness. Cold blue planets surrounded by powerful winds and strange secrets. The first of these distant giants now appears ahead, the tilted and mysterious planet Uranus. As Saturn and its shimmering rings slowly fade into the distance, the sunlight around us grows softer and colder. Far ahead, a faint bluish world begins to appear, drifting quietly through the darkness. This distant planet is Uranus. From afar, Uranus looks calm and almost featureless, a pale blue sphere floating silently in the outer solar system. Unlike Jupiter and Saturn, which display dramatic storms and colorful cloud bands, Uranus appears smooth and peaceful. But beneath this quiet appearance lies one of the strangest worlds in the solar system. Uranus is known as an ice giant, a planet made mostly of water, ammonia, and methane ices mixed with hydrogen and helium gas. These substances form a deep, thick atmosphere that extends thousands of kilometers downward. The pale blue color of Uranus comes from methane gas in its atmosphere. Methane absorbs red light from the sun while reflecting blue wavelengths back into space, giving the planet its soft turquoise glow. Yet the most unusual feature of Uranus is not its color. It is the way the planet spins. Most planets in the solar system rotate like spinning tops, tilted slightly as they circle the sun. Earth, for example, tilts about 23 degrees, which creates our familiar seasons. But Uranus is tilted far more dramatically. Its axis leans over by about 98 degrees. This means Uranus essentially rolls around the sun on its side rather than spinning upright like the other planets. Because of this extreme tilt, the seasons on Uranus are unlike anything else in the solar system. Scientists are still unsure exactly how Uranus became so dramatically tilted. One leading theory suggests that during the early chaotic days of planetary formation, a massive object, perhaps even a young planet, collided with Uranus and knocked it sideways. Over billions of years, the planet continued orbiting the sun while maintaining its unusual orientation. Despite its calm appearance, Uranus is not entirely quiet. Powerful winds race through its atmosphere at speeds of up to 900 kilometers per hour. Hidden storms sometimes appear deep within the clouds, briefly disturbing the planet's smooth appearance. Uranus is also surrounded by a faint system of rings. These rings are much darker and narrower than Saturn's bright icy rings, making them far more difficult to see. They are composed of dark particles of rock and ice quietly circling the planet. Along with these rings, Uranus also hosts a family of moons. 27 moons are currently known, many of them named after characters from the works of William Shakespeare and Alexander Pope. Some of these moons show signs of fractured icy surfaces and ancient geological activity. Yet, compared with the dramatic worlds closer to the sun, Uranus remains a distant and quiet giant. As we continue drifting even farther outward into the cold darkness of the solar system, another blue planet begins to appear, a world known for the fastest winds anywhere among the planets, the deep blue planet Neptune.
As Uranus slowly disappears behind us, the sunlight becomes even fainter and colder. Farther from the warmth of the sun, another deep blue world quietly comes into view. This is Neptune. Neptune is the most distant major planet in the solar system, orbiting the sun nearly 30 times farther away than Earth. At such an incredible distance, sunlight is weak, appearing almost like a bright star rather than the powerful light we experience on our own planet. Yet, despite the cold and dim conditions so far from the sun, Neptune is far from a quiet place.
In fact, Neptune is home to the fastest winds anywhere in the solar system. These extreme winds race through the planet's upper atmosphere at speeds exceeding 2,000 kilometers per hour. That is faster than the speed of sound on Earth and several times faster than the cruising speed of a commercial jet airplane. Scientists believe these extreme winds are powered not only by sunlight, but also by heat rising from deep inside the planet. Even though Neptune receives very little energy from the sun, it radiates more heat than it absorbs. This internal warmth helps drive the planet's violent weather systems. Like Uranus, Neptune's atmosphere is composed mainly of hydrogen, helium, and methane. Methane absorbs red light from the sun, giving Neptune its striking deep blue color. Beneath this outer layer of clouds, the atmosphere becomes denser and hotter as it descends into the planet's interior. Storms occasionally form within these cloud layers. One of the most famous was the Great Dark Spot, a massive storm discovered by the Voyager 2 spacecraft when it flew past Neptune in 1989. Like Jupiter's Great Red Spot, Neptune's dark spots appear and disappear over time as powerful winds reshape the atmosphere. Neptune also possesses a faint ring system. These rings are not bright and icy like Saturn's, but instead are thin, dark bands of dust and small particles orbiting the planet. Some sections of these rings form mysterious clumps known as arcs, where particles appear to gather together rather than spreading evenly. The reason these arcs remain stable is still not completely understood. Orbiting Neptune are several moons as well, each following its own quiet path around the distant planet. The largest of these moons is Triton. Triton is a strange and fascinating world. Unlike most moons, which orbit in the same direction as their planet's rotation, Triton travels in the opposite direction. This unusual motion suggests that Triton may not have formed around Neptune at all. Instead, scientists believe it may have once been an independent object from the outer solar system that was captured by Neptune's gravity long ago. Triton's surface is covered with frozen nitrogen, and in some places, geysers of nitrogen gas erupt from the icy ground, spraying material high into the thin atmosphere. Even this far from the sun, strange activity continues to shape distant worlds. But Neptune is not the final destination of our quiet journey. Beyond its orbit lies a region filled with icy remnants from the earliest days of the solar system, a distant frontier where small frozen worlds slowly circle the sun in deep silence. And among them waits a famous icy dwarf planet, the distant world of Pluto. As Neptune's deep blue glow slowly fades into the darkness behind us, the solar system begins to feel quieter and more distant. The sun now appears much smaller in the sky, shining like a bright star rather than the powerful source of warmth we know on Earth. We have entered the outer frontier of the solar system. This region is known as the Kuiper Belt. The Kuiper Belt is a vast ring of icy objects that stretches far beyond the orbit of Neptune. It contains countless frozen remnants left over from the formation of the planets billions of years ago. Many of these objects are small, only a few kilometers wide, but some are large enough to be considered dwarf planets. Among them is one of the most well-known worlds in the outer solar system, Pluto. For many years, Pluto was considered the ninth planet. Discovered in 1930 by astronomer Clyde Tombaugh, this distant world captured the imagination of scientists and the public alike.
But in 2006, astronomers reclassified Pluto as a dwarf planet when they realized that many similar objects exist in the outer solar system. Even so, Pluto remains one of the most fascinating worlds we have ever explored. For decades, Pluto appeared as little more than a blurry point of light in powerful telescopes. Everything changed in 2015 when NASA's New Horizons spacecraft flew past Pluto and revealed its surface in extraordinary detail. What scientists saw was far more complex and beautiful than anyone expected. One of Pluto's most famous features is a large, bright region shaped roughly like a heart. This area is called Sputnik Planitia. It is a vast basin filled with frozen nitrogen ice that slowly shifts and flows across the surface. The icy plains of Sputnik Planitia are surprisingly smooth and young compared with other regions of Pluto. This suggests that the surface is still slowly changing, even in the extreme cold of the outer solar system. Temperatures on Pluto can fall to around -230 degrees Celsius. At such frigid temperatures, familiar substances behave very differently. Nitrogen, methane, and carbon monoxide can freeze into solid ice, forming glaciers that slowly creep across the landscape. Mountains made of water ice rise several kilometers above the frozen plains. Water ice on Pluto is so cold and solid that it behaves like rock, forming towering peaks and rugged terrain. Scientists studying Pluto have also found evidence suggesting something even more surprising beneath its frozen surface. There may be a hidden ocean. Even though Pluto is incredibly distant from the Sun, heat produced by radioactive elements within its interior might keep a layer of water beneath the crust from freezing completely solid. If this ocean exists, it would lie deep below the surface, sealed under thick layers of ice. Even in the farthest regions of the solar system, liquid water may still exist. Pluto also has its own family of moons. The largest of these is Charon, a moon so large compared to Pluto that the two worlds actually orbit a shared center of gravity in space. Because of this, Pluto and Charon are sometimes described as a binary system. From Pluto's surface, Charon would appear enormous in the sky, hanging almost motionless above the horizon. As we drift quietly beyond Pluto, the solar system grows darker and colder still. Yet even here, far beyond the planets, the story of our cosmic neighborhood continues.
As Pluto and its quiet moons slowly drift behind us, the solar system begins to feel wider and more mysterious. The sun now shines only as a distant point of light, faint but still powerful enough to hold countless objects in its gentle gravitational embrace. We are still within the vast region known as the Kuiper Belt. This distant belt contains thousands of icy worlds slowly circling the sun in long, cold orbits. Many of these objects are small and irregular, but a few are large enough to be considered dwarf planets, each with its own unique story. One such world is Eris. Eris was discovered in 2005 and immediately caused excitement among astronomers. In fact, its discovery played a major role in the debate that eventually led to Pluto being reclassified as a dwarf planet. Eris is slightly smaller than Pluto, but it is more massive and travels on a highly stretched orbit that carries it far beyond the Kuiper Belt for long periods of time. The surface of Eris is extremely bright. This brightness comes from layers of frozen methane ice that reflect sunlight strongly, making the distant world shine like a tiny mirror in the darkness of space. Because Eris travels so far from the Sun, its surface temperatures are among the coldest found anywhere in the solar system. Another distant dwarf planet is Haumea. Haumea is unusual because of its strange, elongated shape. Instead of being round like most large objects in space, Haumea looks more like a stretched oval. Scientists believe this unusual shape formed after a massive collision long ago that spun the dwarf planet rapidly. Haumea rotates incredibly fast, completing a full spin in less than 4 hours. This rapid rotation causes the dwarf planet to stretch outward along its middle, creating its distinctive elongated appearance. Haumea is also surrounded by a thin ring of icy debris and has 2 small moons orbiting nearby. These features likely formed from fragments thrown into space during that ancient collision. Another distant member of this icy family is Makemake. Makemake is slightly smaller than Pluto, but still large enough for its gravity to shape it into a nearly spherical form. Its surface is frozen methane and possibly ethane ice, giving it a reddish tint when viewed through telescopes. Unlike Pluto or Eris, Makemake appears to have very little atmosphere. Any gases that once surrounded the dwarf planet may have escaped into space over time due to its relatively weak gravity. These distant dwarf planets remind us that the solar system is far more populated than we once believed. Beyond the 8 major planets lies a vast collection of frozen worlds quietly orbiting the Sun. Many more dwarf planets are likely to be discovered. Even farther beyond the Kuiper Belt lies an even more distant region of icy objects known as the scattered disk. Some of these objects follow extremely long and tilted orbits that carry them far from the Sun before slowly returning again. And beyond even that distant realm lies one final frontier, a gigantic cloud of icy bodies stretching tens of thousands of astronomical units into space. A distant halo that marks the outermost edge of our solar system, the mysterious and nearly invisible region known as the Oort cloud.
As the icy dwarf planets of the Kuiper Belt slowly fade behind us, the solar system begins to feel quieter than ever before. The familiar planets are now far away, and the Sun has become a small glowing star in the distance. Yet our journey has not reached the end. Far beyond the Kuiper Belt lies a vast and mysterious region known as the Oort cloud. Unlike the asteroid belt or the Kuiper Belt, the Oort cloud is not shaped like a flat ring. Instead, scientists believe it forms an enormous spherical shell surrounding the entire solar system. This distant cloud may extend tens of thousands of astronomical units from the Sun. To understand how far that is, consider this. 1 astronomical unit is the distance between Earth and the Sun, about 150 million kilometers. The outer edge of the Oort cloud may lie nearly 100,000 times farther away than that. At such incredible distances, the Sun would appear only as a very bright star in the sky. The Oort cloud is thought to contain billions, perhaps even trillions of icy bodies. These frozen bodies are leftovers from the early days of planetary formation, scattered outward by the powerful gravitational forces of the giant planets long ago. Most of the time, these distant objects drift silently through the darkness. But occasionally, something disturbs them.
The gentle gravitational pull of a passing star, or even the slow tides created by the gravity of our galaxy, can nudge one of these icy bodies from its quiet orbit. When that happens, the object may begin a very long journey inward toward the sun. These travelers are what we know as comets. As a comet approaches the inner solar system, the increasing warmth of the sun begins to heat its frozen surface. Ice that has remained solid for billions of years suddenly begins to vaporize, releasing gas and dust into space. This creates the glowing cloud around the comet, known as a coma. Solar radiation and streams of charged particles then push this material away from the comet, forming a long, luminous tail that can stretch millions of kilometers across space. The beautiful tails of comets always point away from the sun, glowing softly against the darkness. Some comets pass through the inner solar system only once, traveling along enormous orbits that carry them back into deep space for millions of years. Others return regularly, following predictable paths that bring them back again and again. One famous example is Halley's Comet, which becomes visible from Earth roughly 76 years. When comets pass close to Earth, tiny particles of dust sometimes break away from their trails. If our planet crosses through these streams of debris, these particles burn up in the atmosphere, creating bright streaks of light in the sky. These glowing streaks are what we call meteor showers. So even though the Oort cloud lies unimaginably far away, its icy fragments sometimes visit the inner solar system, leaving brief, sparkling traces in our night sky. And yet, even beyond this immense cloud of distant objects, the story of the sun itself continues. Because our star is not silent. Deep within its blazing layers, it is constantly vibrating, quietly ringing like a cosmic instrument in the darkness of space.
Even though the sun appears calm and steady when viewed from Earth, it is never truly silent. Deep within its blazing interior, powerful movements of hot plasma create vibrations that travel throughout the entire star. In a way, the sun is constantly ringing like a giant musical instrument. These vibrations are far too low for human ears to hear, but scientists can detect them using special instruments. The waves move through the sun's interior, much like sound waves traveling through air. This field of study is called helioseismology. By observing the subtle motions of the sun's surface, scientists can learn about what is happening deep inside the star. Much like geologists use seismic waves from earthquakes to study Earth's interior, solar scientists use these vibrations to map the hidden layers of the sun. The sun is made mostly of hydrogen and helium, but it is not solid. Instead, it is a vast sphere of extremely hot plasma. In its outer layers, this plasma rises and falls in slow rolling currents. Hot material rises toward the surface, cools slightly, and then sinks again in a constant cycle of motion. These movements create waves that ripple throughout the star. Some of these waves travel directly through the sun's interior, while others bounce around inside it like echoes inside a great cosmic chamber. By carefully measuring how these waves move, scientists can estimate the temperature, density, and movement of material inside the sun. These discoveries have revealed that the sun rotates in a surprising way.
Unlike a solid planet, the Sun does not rotate as one single piece. Its equator rotates faster than its poles. Near the equator, one rotation takes about 25 Earth days, while near the poles, it takes closer to 35 days. This difference in rotation causes the Sun's magnetic field to twist and stretch over time. Eventually, the magnetic field becomes tangled and unstable. When that happens, enormous bursts of energy can erupt from the Sun's surface in the form of solar flares and massive clouds of charged particles known as coronal mass ejections. These eruptions can travel across the solar system and sometimes reach Earth. When they interact with Earth's magnetic field, they can create beautiful auroras near the polar regions. These glowing curtains of light shimmer across the night sky in shades of green, red, and purple. Though the Sun feels peaceful from our distance, it is actually a dynamic and constantly changing star. And yet, compared with many stars in the universe, the Sun is considered remarkably stable. It has been shining steadily for about 4.6 billion years, providing the energy that allowed life to develop on our small planet. But the Sun will not shine forever. Deep within its core, hydrogen fuel is slowly being consumed through nuclear fusion. Over billions of years, this fuel supply will gradually decrease, causing the Sun to change in ways that will reshape the entire solar system. For now, however, the Sun continues to glow quietly in the darkness, and around it, the planets continue their slow and graceful dance through space.
As we continue drifting quietly through the solar system, the distant Sun still glows behind us like a steady golden beacon. Around it, every planet, moon, and fragment of rock continues its slow and graceful motion, guided by one powerful force: gravity. Gravity is the invisible thread that holds the entire solar system together. Without it, the planets would not orbit the Sun, moons would drift away from their worlds, and asteroids would wander endlessly through space. Instead, gravity creates order within the vast emptiness. Every object with mass produces gravity. Even small rocks in space pull gently on the objects around them. But when enormous bodies like planets and stars are involved, the pull becomes powerful enough to shape entire systems. The Sun contains more than 99% of all the mass in the solar system. Because of this overwhelming mass, its gravity dominates everything nearby. Planets follow curved paths around the Sun known as orbits, moving through space in a delicate balance between motion and gravitational pull. If a planet were to stop moving sideways through space, the Sun's gravity would pull it directly inward. But because planets are already moving forward through space, they continuously fall around the Sun rather than straight into it. This constant falling creates the elegant looping paths we call orbits. These orbits are not perfect circles. Instead, they are slightly stretched shapes known as ellipses. Sometimes a planet moves a little closer to the Sun during its orbit, and sometimes a little farther away. Even small differences in distance can influence the temperatures and conditions on a planet. Earth, for example, follows a nearly circular orbit, which helps maintain relatively stable seasons over long periods of time. But some objects in the solar system follow far more unusual paths. Certain comets travel on extremely elongated orbits that carry them deep into the outer solar system before bringing them briefly close to the Sun again. These journeys can take thousands or even millions of years to complete. Gravity also shapes the behavior of moons. Many planets have their own systems of moons, each orbiting according to the gravitational pull of its parent world. Some moons move in nearly perfect circles, while others follow slightly tilted or stretched paths. Occasionally, gravity creates even more complex relationships. Some moons become locked in what scientists call orbital resonance. This means their orbits are synchronized in repeating patterns. For example, Jupiter's moons, Io, Europa, and Ganymede, are locked in a precise gravitational rhythm. Every time Ganymede completes one orbit, Europa completes two, and Io completes four. This repeating pattern keeps their gravitational interactions stable over long periods of time. Gravity also shapes the rings of planets like Saturn. The countless icy particles within those rings constantly interact with the planet's gravity as well as with the gravity of nearby moons. These delicate interactions help maintain the thin, elegant structures that circle the giant planet. Even the asteroid belt owes its structure to gravity. The powerful gravitational pull of Jupiter prevents those rocky fragments from gathering together into a full planet. Instead, they remain scattered remnants of the solar system's early history. And through it all, gravity continues its quiet work, guiding every orbit, holding every world in place, and maintaining the delicate balance that allows our solar system to exist.
As the quiet pull of gravity continues to guide every planet and moon through space, another silent process is always unfolding throughout the solar system: time. The solar system is incredibly ancient. Scientists estimate that it formed about 4.6 billion years ago from a vast cloud of gas and dust drifting through our region of the galaxy. Over time, gravity slowly gathered this material together, forming the Sun at the center and the planets that now circle around it. In those early days, the solar system was a far more chaotic place than it is today. Young planets collided with one another. Fragments of rock flew through space, and enormous impacts reshaped entire worlds. During this violent period, many of the craters we see today on planets and moons were formed. The moon, for example, is covered with countless circular scars from ancient impacts. Mars also carries the marks of these early collisions across its dusty surface. Even Mercury, the small planet closest to the Sun, bears the evidence of countless impacts that occurred billions of years ago. Over time, however, the solar system gradually became calmer. Most of the leftover debris from planet formation either collided with larger bodies or was pushed into distant regions like the asteroid belt and the Kuiper belt. As a result, the number of major impacts decreased dramatically. Yet the solar system is still slowly changing. Asteroids occasionally collide with one another, breaking apart into smaller fragments. Comets continue to travel inward from distant regions like the Oort cloud, briefly visiting the inner solar system before returning to deep space. Even the Sun itself continues to evolve. Every second, the Sun converts millions of tons of hydrogen into helium through nuclear fusion. Though this loss of mass is tiny compared with the Sun's enormous size, it slowly changes the star over billions of years. Stars, like all things in the universe, are not permanent. They are born, they change, and eventually they reach the end of their lifetimes. For now, however, the Sun remains stable and bright, providing the energy that sustains the solar system. Around it, the planets continue their steady orbits, each world following its path through the darkness of space. And as we drift peacefully through this vast cosmic neighborhood, one final quiet truth becomes clear. Even in the immense emptiness of space, everything is connected through time, motion, and gravity. As our quiet journey through the solar system continues, it becomes clear that many of the worlds we have visited are far from simple. Beneath calm surfaces and silent skies, hidden processes continue shaping these distant places. One of the most surprising discoveries in modern planetary science is that oceans may exist in many places beyond Earth. Not oceans under open skies like our own, but oceans hidden beneath thick layers of ice. Europa, the icy moon of Jupiter we visited earlier, is one of the best examples. Beneath its frozen crust, scientists believe a vast global ocean of liquid water may exist. The constant gravitational pull of Jupiter flexes the moon's interior, creating heat that may keep this ocean from freezing completely solid. But Europa may not be the only ocean world. Another moon of Jupiter, called Ganymede, may also contain multiple layers of underground oceans trapped between thick shells of ice. These oceans could be stacked like layers in a frozen sandwich deep beneath the surface. Saturn's moons may hide similar secrets. Enceladus, a small icy moon orbiting Saturn, has astonished scientists with powerful geysers that erupt from cracks near its south pole. These plumes spray water vapor, ice particles, and organic molecules high into space. When spacecraft flew through these plumes, instruments detected signs of salty water and complex chemicals. This strongly suggests that Enceladus hides a warm ocean beneath its icy shell. Deep below the frozen surface, tidal forces from Saturn may generate enough heat to maintain liquid water. Some scientists even suspect that hydrothermal vents could exist on the ocean floor, much like those found in Earth's deep oceans. These vents could provide energy and nutrients that might allow simple forms of life to develop. Titan, Saturn's largest moon, may also contain a hidden ocean beneath its icy crust. Although Titan's surface is dominated by lakes and rivers of liquid methane, scientists believe a deep ocean of water mixed with ammonia may lie far below the surface. Even distant Pluto may hold a subsurface ocean trapped beneath layers of frozen nitrogen and water ice. The idea that oceans might exist on so many worlds has changed how scientists think about life in the universe. For a long time, Earth was believed to be unique because of its oceans. But now we know that liquid water may be far more common than once imagined, hidden beneath frozen shells across the solar system. These ocean worlds remain dark and mysterious. Their waters lie far beneath thick layers of ice, far from the warmth of sunlight, yet they may still contain the ingredients necessary for life. Future missions may one day explore these hidden seas. Robotic probes could drill through icy crusts or send instruments into plumes of water erupting from distant moons. Each discovery would bring us closer to understanding whether life might exist beyond Earth. For now, however, these oceans remain silent, quiet seas beneath frozen worlds. And as we continue drifting slowly through the vastness of space, the solar system still holds many secrets waiting to be discovered.
As we continue drifting quietly through the outer reaches of the solar system, it becomes easier to appreciate just how vast this cosmic neighborhood truly is. The planets we know may seem far apart on a map, but the real distances between them are almost impossible to imagine. Space is mostly empty. For example, if the sun were the size of a large beach ball sitting at the center of a field,
Earth would be no bigger than a small marble placed about 25 meters away. Jupiter would be another marble far across the field, and Neptune would sit hundreds of meters away near the edge of the park. Between these worlds would be almost nothing. This emptiness is why spacecraft can travel for years through the solar system without encountering any obstacles. Even the asteroid belt, which sounds crowded, is mostly a vast region of open space with only occasional rocky fragments drifting along their orbits. Yet within this emptiness, something remarkable still happens. Sunlight continues to travel outward. Every second, the sun sends enormous amounts of energy streaming into space. This light spreads in all directions, gradually growing weaker as it travels farther away. By the time sunlight reaches Neptune, it is about 900 times dimmer than it is on Earth. Still, it is enough to illuminate distant worlds and faintly warm their surfaces. Beyond Neptune, sunlight grows even fainter as it spreads across the Kuiper belt. Here, the sun appears more like a brilliant star than a blazing disk. But even at these extreme distances, the sun's influence continues. Its gravity still holds distant objects in orbit, keeping them bound to the solar system. Even comets traveling from the faraway Oort cloud remain connected to the sun's pull, though their journeys may take millions of years to complete. And beyond these distant objects lies the boundary where the solar system slowly begins to merge with interstellar space. This boundary is called the heliosphere. The heliosphere is a vast bubble created by the solar wind, a continuous stream of charged particles flowing outward from the sun. These particles spread through space at high speeds, forming a protective shield that surrounds the solar system. Eventually, however, the solar wind begins to weaken as it pushes against the thin gas that exists between the stars. At that distant boundary, the solar wind slows dramatically. This region is known as the termination shock. Farther still lies the heliopause, the place where the influence of the sun's solar wind finally balances with the pressure of interstellar space beyond. When spacecraft cross this invisible boundary, they are no longer traveling through the sun's protective bubble. They have entered interstellar space. 2 spacecraft built by humans have already reached this distant frontier. Voyager 1 and Voyager 2 were launched in the late 1970s to explore the outer planets. After completing their planetary missions, they continued drifting outward, carrying golden records filled with sounds and images from Earth. Today, these spacecraft continue drifting into the vast darkness between the stars. Quiet travelers carrying a small message from humanity. And even now, they move steadily farther away from the sun, deeper into the immense ocean of the galaxy. As the Voyagers continue their silent journey beyond the heliosphere, the solar system slowly fades behind them. The sun, once a brilliant center of warmth and light, becomes just another star among billions scattered across the galaxy. Yet even at these incredible distances, the story of our solar system remains deeply connected to the larger universe around it. Our solar system does not exist alone in space. It is part of a vast galaxy known as the Milky Way. The Milky Way is an enormous spiral galaxy containing hundreds of billions of stars, each with its own planets, moons, and possibly even entire systems of worlds. From within the galaxy, our sun quietly orbits the galactic center, traveling through space at a speed of roughly 220 kilometers per second. Even at that immense speed, one full orbit around the galaxy takes about 230 million years. That means the last time the Sun was in its current position within the Milky Way, dinosaurs were just beginning to appear on Earth. The Sun and its family of planets drift through one of the galaxy's spiral arms, surrounded by clouds of gas, dust, and distant stars. Occasionally, our solar system passes through regions where stars are more densely packed together. At other times, it moves through quieter stretches of space. These long galactic journeys may influence the solar system in subtle ways. For example, passing stars can slightly disturb the distant objects in the Oort cloud. Over millions of years, these gentle gravitational nudges may send new comets drifting toward the inner solar system. So even events occurring many light years away can slowly affect the environment around our Sun. Yet compared with many places in the galaxy, our solar system occupies a relatively calm neighborhood. We are far from the violent center of the galaxy, where dense clusters of stars and powerful radiation make conditions far more dangerous for planetary systems. Instead, the Sun resides in a quieter region, sometimes called the galactic suburbs. This peaceful location may have helped allow life to develop on Earth. Too close to the galactic center, intense radiation from nearby stars and supernova explosions could make life far more difficult. Too far out, there might not be enough heavy elements to form rocky planets at all. But here, in this balanced region of the galaxy, our solar system has been able to exist for billions of years. And during that time, the Sun has remained a steady source of light and warmth. Planets have continued their slow orbits. Moons have circled their worlds, and small fragments of rock and ice have drifted quietly through the darkness. From this distant perspective, the solar system appears like a delicate clockwork mechanism, each part moving according to the same universal laws of gravity and motion. Yet within this quiet cosmic system, one small blue world developed something rare and remarkable: life. And as our peaceful journey through the solar system continues, we begin to reflect on just how unusual that tiny living planet truly is.
As we slowly drift back in thought toward the inner regions of the solar system, one small blue world stands out among all the others we have visited: Earth. Among the many planets and moons circling the Sun, Earth appears remarkably balanced. Its distance from the Sun allows temperatures that are neither too hot nor too cold for liquid water to exist on the surface. This region is often called the habitable zone. Within this comfortable range of distance, water can remain liquid for long periods of time. On Earth, that water formed vast oceans covering most of the planet's surface, creating the environment where life eventually emerged. But Earth's habitability is not the result of distance alone. Several factors combine to create the stable conditions that life depends on. One of the most important is Earth's atmosphere. Our atmosphere is made primarily of nitrogen and oxygen, with small amounts of other gases such as carbon dioxide and water vapor. This mixture allows sunlight to warm the surface while also trapping enough heat to keep temperatures relatively stable. Without this natural greenhouse effect, Earth would be far colder. At the same time, the atmosphere protects the planet from harmful radiation coming from space. High in the upper layers of the atmosphere, a thin region known as the ozone layer absorbs much of the sun's ultraviolet radiation before it can reach the surface. Another important factor is Earth's magnetic field. Generated by the movement of molten iron in the planet's outer core, this invisible magnetic shield extends far into space. It deflects charged particles from the sun, preventing them from slowly stripping away the atmosphere. Mars, for example, once had a thicker atmosphere and flowing water, but after losing its global magnetic field billions of years ago, much of its atmosphere was gradually lost to space. Earth also benefits from the presence of its large moon. Our moon helps stabilize the tilt of Earth's axis, preventing extreme variations in climate over long periods of time. The moon's gravity also creates ocean tides, which may have played an important role in the early development of life along Earth's coastlines. Deep inside the planet, plate tectonics continues to reshape the surface. The slow movement of continents recycles carbon dioxide through volcanic activity and rock formation, helping regulate Earth's climate over millions of years. These combined processes create a system that remains stable yet constantly changing. Mountains rise and slowly erode. Oceans circulate heat across the globe. Forests grow, rivers flow, and life continues adapting to the shifting environment. From space, Earth appears peaceful and fragile. Thin layers of atmosphere cling to the surface, oceans reflect the sunlight, and clouds drift across the continents below. Among all the worlds in the solar system, Earth remains the only one known to host life. And as we continue our gentle journey through the quiet architecture of the solar system, we begin to realize something remarkable. Even though our cosmic neighborhood is vast and filled with extraordinary worlds, this small blue planet remains uniquely alive. As we continue drifting quietly through the solar system, another fascinating truth slowly becomes clear. The planets we have visited may seem very different from one another, yet they all formed from the same ancient cloud of gas and dust billions of years ago. Long before Earth, Mars, or Jupiter existed, our solar system began as a vast rotating cloud known as a solar nebula. This cloud contained mostly hydrogen and helium, along with tiny grains of dust made from heavier elements created in earlier generations of stars. Slowly, gravity began pulling this cloud inward. As the cloud collapsed, it started spinning faster and faster. Eventually, most of the material gathered at the center, forming the young sun. Around this newborn star, the remaining gas and dust flattened into a wide rotating disk. Within this disk, tiny particles began sticking together. At first, they formed tiny grains and pebbles. Over time, these pieces collided and merged, gradually building larger and larger bodies. This slow process of accumulation is called accretion. As these growing objects became larger, their gravity began attracting even more material. Some eventually grew into planetesimals, bodies large enough to influence their surroundings gravitationally. Through countless collisions and mergers, these planetesimals eventually formed the planets we know today. Closer to the sun, where temperatures were extremely hot, only rock and metal could remain solid. This is why the inner planets, Mercury, Venus, Earth, and Mars, are made mostly of dense, rocky material. Farther from the sun, temperatures were much colder. In these distant regions, lighter substances such as water, ammonia, and methane could freeze into ice. These frozen materials helped form the large cores of the giant planets.
Once these cores became massive enough, they began pulling enormous amounts of hydrogen and helium gas around them. This process created the massive gas giants Jupiter and Saturn, as well as the icy giants Uranus and Neptune. Even after the planets formed, the solar system continued to evolve. Some leftover fragments became asteroids and comets. Others collided with planets or were flung outward into distant regions like the Kuiper Belt and the Oort cloud. Over millions of years, the chaotic early solar system slowly settled into the more stable structure we see today. Yet, traces of that ancient past remain everywhere. The craters on the Moon and Mercury preserve the scars of early collisions. Asteroids drifting through space still carry the original materials from which the planets formed. Meteorites that fall to Earth often contain minerals older than our planet itself. By studying these ancient fragments, scientists can piece together the history of how our solar system formed and evolved over billions of years. In a sense, every planet and moon we have visited on our journey is a survivor of that long and violent beginning. From fiery collisions and swirling clouds of dust, a stable system of worlds eventually emerged. A quiet family of planets slowly circling their star. And as we continue our peaceful journey through this cosmic neighborhood, we begin to see how delicate and remarkable that long process truly was. As we reflect on the ancient birth of the solar system, another quiet realization begins to appear. The sun and its planets may feel permanent to us, but in the grand timeline of the universe, even stars have lifetimes. Like all stars, the sun was born. It is slowly evolving, and one day it will eventually change in dramatic ways. Right now, the sun is in what astronomers call the main sequence stage of its life. During this long and stable phase, the sun steadily converts hydrogen into helium through nuclear fusion in its core. This process releases enormous amounts of energy. That energy travels outward through the sun and eventually radiates into space as the light and warmth that reaches Earth and the other planets. The sun has been performing this quiet fusion for about 4.6 billion years, and it will likely continue doing so for about another 5 billion years. But stars do not remain the same forever. As hydrogen in the sun's core slowly runs out, the balance between gravity and fusion will begin to change. The core will gradually shrink under its own gravity, becoming hotter and denser. Meanwhile, the outer layers of the sun will begin to expand. Over millions of years, the sun will grow larger and larger, eventually transforming into what astronomers call a red giant. During this phase, the sun could expand far enough to swallow the inner planets. Mercury and Venus will almost certainly be engulfed by the expanding star. Earth's fate is less certain, but even if our planet escapes being swallowed directly, its surface will become far too hot for oceans or life to survive. The oceans would slowly evaporate, and the atmosphere would eventually drift away into space. But this transformation will not happen suddenly. The sun's changes will unfold slowly across millions of years. Eventually, after the red giant phase, the sun will shed its outer layers into space, forming a glowing cloud of gas known as a planetary nebula. At the center of this expanding cloud, the remaining core of the sun will shrink down into a dense object called a white dwarf. A white dwarf is extremely small compared to a normal star, but it remains incredibly hot. Over billions of years, however, even this remnant will gradually cool and fade. Long after the planets have changed and the sun's light has dimmed, the white dwarf will continue glowing faintly as it slowly releases the last of its stored heat. This distant future reminds us that the solar system, like everything in the universe, is always evolving. Stars are born, they shine for billions of years, and eventually they transform. But for now, the sun remains a stable and steady star. Its light continues to travel outward through space. Its gravity continues guiding the planets along their quiet paths. And within this calm cosmic system, life on Earth continues to exist under the gentle warmth of our star. As we continue drifting quietly through the vastness of space, another gentle thought begins to emerge. Our solar system may feel enormous, yet compared with the wider universe, it is only a tiny island in an immense cosmic ocean. Beyond our sun lie countless other stars. Many of them are surrounded by their own families of planets, known as exoplanets. These distant worlds orbit stars scattered throughout the Milky Way, sometimes hundreds or thousands of light years away from us. For a long time, scientists could only wonder if such planets existed. But over the past few decades, powerful telescopes and space missions have revealed thousands of these distant worlds. Some are giant gas planets larger than Jupiter. Others are rocky planets similar in size to Earth. Some orbit extremely close to their stars, completing an entire year in just a few days. Others circle much farther away, moving slowly through the cold darkness of space. Each new discovery reminds us that planetary systems may be common throughout the galaxy. Many of these distant systems look very different from our own. In some places, giant planets orbit extremely close to their stars. These worlds are sometimes called hot Jupiters, where temperatures are so high that their atmospheres glow under intense stellar radiation. In other systems, planets follow unusual or tilted orbits, suggesting that their histories involved powerful gravitational interactions. Compared with these strange systems, our solar system appears remarkably orderly. The planets move in nearly circular paths within roughly the same flat plane. Rocky planets occupy the inner region, while gas and ice giants dominate the outer regions. This relatively stable structure may have helped create the long-term stability needed for life to develop on Earth. Astronomers are especially interested in finding planets that lie within the habitable zones of their stars. In these regions, temperatures may allow liquid water to exist on a planet's surface. Some of the exoplanets discovered so far appear to be roughly Earth-sized and located within these habitable zones. Although we do not yet know whether life exists on any of these distant worlds, the possibility is deeply fascinating. Each new discovery expands our understanding of how planets form and how common life-friendly environments might be throughout the universe. At the same time, these discoveries also remind us how special our own planet is. Among the many worlds we have observed, Earth remains the only place where life is known to exist. Its oceans, atmosphere, and living ecosystems make it unique among the planets we have studied. Yet the universe is vast. With hundreds of billions of stars in our galaxy alone and billions of galaxies across the cosmos, the number of possible worlds is almost beyond imagination. Somewhere among those distant stars, other planets may also orbit quietly in the warmth of their suns. For now, though, our peaceful journey brings us back to the familiar family of worlds that circle our own star. a quiet system of planets, moons, and drifting fragments bound together by gravity. Our home in space.
As our slow journey through the solar system continues, a gentle sense of perspective begins to settle in. After drifting across planets, moons, rings, and distant icy worlds, it becomes clear that the solar system is not just a collection of objects. It is a quiet, interconnected system. Every planet, every moon, and even the smallest fragments of dust move according to the same fundamental laws of nature. Gravity guides their paths, energy flows from the sun, and time slowly shapes their surfaces. Even the smallest details play a role. Tiny grains of dust drift between planets, forming what scientists call interplanetary dust. When sunlight reflects off these particles, it sometimes creates a faint glow in the sky, known as zodiacal light. This soft, triangular glow can occasionally be seen from Earth just after sunset or before sunrise in very dark skies. It is a reminder that the solar system is filled with countless small particles quietly floating between the larger worlds. Occasionally, some of these particles enter Earth's atmosphere. When they burn up in the upper atmosphere, they create the brief streaks of light we call meteors. On clear nights, patient observers may see several of these tiny flashes of light crossing the sky. During certain times of the year, Earth passes through streams of dust left behind by comets. When this happens, dozens or even hundreds of meteors may appear in a single night, creating what we know as meteor showers. One of the most famous of these events occurs each August during the Perseid meteor shower. These glowing streaks are actually small particles of comet dust, often no larger than grains of sand, burning up high above the Earth's surface. Even the most delicate fragments of the solar system continue to interact with our planet. Meanwhile, farther out in space, planets continue their silent motion. Jupiter's storms swirl endlessly. Saturn's rings shimmer under distant sunlight. Uranus rolls sideways through its long seasons, and Neptune's powerful winds race through the dark blue atmosphere. Beyond them, frozen dwarf planets and distant comets circle the sun in slow and patient orbits that can last thousands or even millions of years. Yet through all of this motion, the solar system remains remarkably stable. The same gravitational balance that formed billions of years ago continues guiding the planets today. Each world follows its own quiet path around the sun, maintaining the delicate harmony that holds the entire system together. And at the center of it all, the sun continues to shine. Its light spreads outward across billions of kilometers of space, warming planets, illuminating moons, and gently touching even the most distant icy bodies. For billions of years, this steady light has shaped the solar system, and for billions more, the quiet dance of worlds will continue under its glow. As our calm journey slowly nears its end, the solar system feels less like a collection of distant objects and more like a quiet story unfolding over billions of years. Every world we visited carries a piece of that story. Mercury, scorched by the nearby sun, turns slowly under a sky that never turns blue. Venus hides its blazing surface beneath thick layers of cloud. Earth shines as a rare blue world filled with oceans and life. Mars holds the silent memory of ancient rivers and towering volcanoes. Farther out, the giant planets rule their distant regions. Jupiter's storms swirl endlessly, powerful winds racing across its enormous atmosphere. Saturn drifts gracefully through space, surrounded by its fragile rings of ice. Uranus rolls sideways along its orbit, its poles spending decades in sunlight and darkness. Neptune, deep in the cold outer solar system, sends supersonic winds racing through its deep blue clouds. Beyond them lie frozen dwarf planets and drifting comets. These distant travelers carry the ancient materials left behind when the solar system first formed. They are quiet reminders of a time when planets were still growing and collisions were common. Together, all these worlds move in harmony around the Sun. Each orbit follows a path shaped by gravity, a delicate balance that has remained stable for billions of years. Though the planets appear to wander slowly through the night sky when seen from Earth, their motions follow precise patterns that scientists can calculate far into the future. Yet, despite this sense of order, the solar system is not frozen in time. Planets continue to evolve. Asteroids still collide. Comets still travel inward from the distant edges of the system. Even the Sun itself slowly changes as it quietly converts hydrogen into energy deep within its core. Everything in the solar system is part of an ongoing process. Mountains rise and erode. Atmospheres shift and move. Storms appear and fade. Ice forms and melts across distant moons. From the perspective of human life, these changes often seem unimaginably slow, but across millions and billions of years, the solar system is always transforming. Still, through all these gradual changes, the quiet beauty of our cosmic neighborhood remains. The Sun shines steadily at the center. Planets glide along their invisible paths. Moons circle their worlds in silent companionship. And in the vast darkness of space, this family of worlds continues its graceful dance. As we gently drift back from this long journey, one final thought remains. Among all the planets, moons, and distant icy bodies we have explored, one small blue world continues to stand out. A world filled with oceans, clouds, forests, and life. A place where conscious beings can look up at the night sky and wonder about the universe around them. That world is our home, Earth. And now, as our long and gentle journey through the solar system slowly comes to a close, the quiet vastness of space feels a little more familiar. We have drifted past scorching worlds close to the Sun, icy moons hiding oceans beneath frozen crusts, giant planets wrapped in storms, and distant dwarf planets slowly circling in the deep cold of the outer solar system. Each world carries its own story. Some are violent and turbulent, shaped by winds, eruptions, and collisions. Others are silent and frozen, unchanged for billions of years. Yet all of them move together in a delicate cosmic rhythm, guided by gravity and time. At the center of this quiet system, the Sun continues to shine. Every second, it releases enormous amounts of energy, sending light across billions of kilometers of empty space. That light warms planets, illuminates moons, and quietly travels outward toward the farthest edges of the solar system. Some of that sunlight reaches Earth in just 8 minutes. It touches oceans, forests, deserts, and mountains. It fuels the plants that grow, the winds that move through the atmosphere, and the countless living things that share this small blue world. Among all the places we have visited in our journey, Earth remains uniquely alive. It is a planet where oceans flow beneath moving clouds, where forests grow and seasons change, and where life has evolved in countless forms over billions of years. From the perspective of space, Earth appears fragile. Its atmosphere is only a thin layer wrapped around the surface. Its oceans are shallow compared with the size of the planet. Yet within those delicate layers exists a vibrant and complex world. A world capable of observing the universe itself. Humans, with their curiosity and imagination, have built telescopes that peer deep into space. We have sent spacecraft across the solar system, exploring distant planets and moons that once existed only as tiny points of light in the sky. Two small spacecraft, Voyager 1 and Voyager 2, are even now traveling beyond the solar system, carrying golden records filled with sounds and images of life on Earth. These quiet travelers may drift among the stars for millions of years. Perhaps one day, somewhere far in the future, another civilization might discover them. For now, however, they continue their silent journey through interstellar space. And here, within the gentle glow of the sun, the planets continue their endless motion. Mercury circles swiftly near the sun. Venus glows beneath thick clouds. Earth turns quietly with its oceans and life. Mars waits with its ancient deserts. The giant planets drift far beyond, surrounded by their moons and rings. And across the vast darkness between them all, gravity continues its quiet work, holding everything together, guiding every orbit, maintaining the delicate harmony of our solar system. So as the night grows deeper and your thoughts begin to slow, imagine yourself drifting gently among these distant worlds, quiet planets, silent moons, endless